Good morning, everyone, and welcome to today's webinar. My name is Martin Damon, and I'm the lead technical specialist at TruckScience. We're hosting this webinar in conjunction with CTEA, and I extend a special welcome to all members joining us today. We partnered with CTEA in 2024, and this partnership gives members access to our axle weight calculator at reduced rates. This webinar will cover the configuration of efficient vehicles that comply with manufacturer limits and the regulations in the different Canadian provinces. We'll start off with the dump truck in Ontario, but also validate our build against the regulations for Quebec and Alberta. I'll also demonstrate how the configuration will need to be altered to achieve optimal results in each of the provinces. To demonstrate the process of configuring an efficient vehicle, I'll take you through a live demo using our axle weight calculator. We'll start off with a set forward axle 6x4 chassis and add an 18-foot dump body. Here we want to determine our baseline carrying capacity under the Ontario SPIF regulations. I'll also add a bobcat trailer to show you this commonly used option. Next, we'll add a pusher axle and a 19-foot body and determine our new carrying capacity when applying Schedule 23 of the Ontario SPIF regulations. I'll also switch the vehicle to a set back axle option with a slightly longer body to demonstrate how this affects the weight carried by the front axle. Then in step 3, I'll change the regulations to Quebec and highlight an important requirement for the second steering axle. And finally, we'll switch to Alberta, where we need to change to a tri-drive option to optimize our dump truck. I'll also add a full trailer here to set up a common combination for this region. Paul, are there any questions before I switch to the live demo?
No, I don't see any questions coming through yet.
All right, so please, you're welcome to use that Q&A feature, and Paul will either answer those questions directly or I'll from time to time check in with Paul, and we can probably give live feedback on that as well.
Great.
Okay, so I will switch to the live demo now. All right, so for our first case study with the 18-foot dump body, we'll choose a vehicle from one of these manufacturers. I'll select a Freightliner 114 severe duty. Let's choose a 6x4, and I will search for the new spec with a set forward axle and choose this one here without the front extension. This vehicle is already pre-configured with some default dimensions and weights, but it's always a good idea to check the spec of the vehicle against the proposal document that you have from your chassis supplier. For example, you may need to change the wheelbase. I'll just increase the wheelbase here, or you can decrease it again. So that option is available. You can also change the bogie spread and the after frame. I'll come back to the after frame once we've added our body. If we have a look at our weights table, we can see that the chassis weighs just over 18,000 pounds. And we also have fuel and crew that gets added to that at about 800 pounds. If we need to make a change to the chassis or to the chassis weight, we can drill down on the front or rear axle weights, where we can then override those values and specify more accurate values from the chassis supplier. You can also update the gross axle weight rating. This is the lesser of the manufacturer's axle, suspension, and tire ratings. I'll come back to the regulation limit here, which is currently just under 20,000 pounds. That is actually 9 tons in the metric measurement system and relates to the limit on the front axle under the Ontario SPIF regulations. But for now, I just want to keep the measurement system on imperial because it's easier to set up the vehicle because all the specs for the vehicle are typically provided in the imperial measurement system. but I'll switch it to the metric weights in a minute. So what we also want to do is just have a quick look at the tires for the front axle, and especially the tire width, because Ontario has a limit on the weight that the axle can carry based on the tire width, which is 11 kilograms per millimeter of tire width. So we need at least a 425/65 R22.5 tire on the front, and that tire has a width of 16.7 inches. If we go to the rear axles, we can make the same changes to the chassis weight and the gross axle weight rating. And again, we can have a look at the tires. The tires here are your typical 11R 22.5 tires. At the rear, the tire restriction is 10 kilograms per millimeter of tire width. But because we have dual-tired fitment at the rear, this limit hardly ever comes into play. If we go have a quick look at the total here, we'll see that the GVWR is currently 68,000 pounds. And I'll come back to that later on when we add our pusher axle, because we'll need to increase that to take full advantage of the extra carrying capacity that we get from the pusher axle. But I'll leave it at 68,000 pounds for now. I already mentioned the fuel and the crew, which gets added to the chassis weight. So we've got a 100-gallon fuel tank and a 13-gallon DEF tank. The fuel is typically excluded from the chassis weight, which is why we add it as an extra weight. In this case, the manufacturer has actually included the DEF in the chassis weight, so we don't need to add that on top of the chassis weight. All right, let's have a look at those permissible values in the weights table now. And for that, I will switch the measurement system to a mix of, or a combination of metric and imperial. So you'll notice that the dimensions are still in imperial, which is useful for making any changes to the spec of the vehicle, but our permissible values are now in kilograms, and they are more meaningful because we can now see that we have 9 tons on the front axle, 18 tons on the rear, and 27 tons for the total. If we're not sure about the regulation against which we are validating, we can drill down on the regulatory compliance here on the dashboard, where we can see that we are validating against the Ontario SPIF regulations. We also validate the calculation against the manufacturer limits and even your own organization standards. I've also added some favorite measurements here, specifically the gross weight of the vehicle that is carried by the front axle. This will play an important role when we add our pusher axle, because it's always tricky to get sufficient weight onto that front axle. I'm also keeping an eye on the turning radius, because there are some cases where we have minimum wheelbase requirements, and that will affect the turning radius. And since this is not regulated, I've set up my own sort of limit on how big the turning radius can be. Okay, so once the chassis is all set up and matches our proposal document from the chassis supplier, we're ready to add the body. So I'll choose a dump body from these different body types. There are different ways in which you can add a body. You can either choose a fully customizable template, or you can pick an existing body from a manufacturer that is already available in the public or distributor library, or you can use the DXF import feature to add your own bodies and equipment. So if you are a bodybuilder and you have dealers or distributors for your products, you have the option of setting up a distributor library and approving who has access to your products. So for our case study today, I'll choose this 18-foot body from Borok and add that to our chassis. Default clearance to the cab is 3 inches. I will make that a little bit bigger, and I'll drag that body back to give it a clearance of about 6 inches. And I'll also cut the after frame a little bit shorter, just to line up more or less just behind the tire of the rearmost axle so that we can dump that body more easily. All right, we still need a hoist for our dump body, so we'll go back to equipment and I'll choose that from other equipment. And I'll just search for a hoist here and just choose a sample dump body hoist and move that into the doghouse. Right, the software will now calculate our payload, which at the moment is 15 tons. We can also see the weight of the body here. It's almost 2.2 tons. And you'll also find those values in the weights table at the bottom. So you see the body weight. You can see that that hoist weighs about 400 kilograms. And our payload is currently 15 tons, limited by the rear axle, which is highlighted to be at 100% here. So we still have about 800 kilograms unused capacity on the front axle and on the total. So to increase our payload carrying capacity here, we could load this vehicle slightly heavy up front. So what I'll do is I'll move the center of gravity of the payload forward slightly until our limiting factor is the front axle. And you'll notice how the payload increases as I move that center of gravity forward. Until the front axle becomes the limiting factor, I'll just move that back a bit. That's more or less the optimum payload that we'll get for this vehicle. So about 15.7 tons, call it almost 16 tons. Now, this is quite a big body for such a small payload, and it's always a useful exercise just to consider the commodity that you want to load in here and to calculate the cubic capacity of the body, and then just to determine whether the body is correctly spec'd for the commodity that we will be loading. So I've calculated this body to have a cubic capacity of about 600 cubic feet. And let's assume we are loading gravel, and gravel weighs about 95 pounds per cubic foot. So that means if we load this body full to the top, it'll actually be about 26,000 kilograms. So if we put 26,000 kilograms into this body, you'll notice that we are overloading all the axles and the total by quite a significant amount. And the dashboard will also indicate this with a red cross next to manufacturer limits and regulatory compliance. However, if, for example, you're loading a lighter commodity, let's take, for example, snow. Snow only weighs 45 pounds per cubic foot, and for 600 cubic feet, that would only be about 12 tons, and that would load this body to the brim. So in this case, you may want to extend the sides with wooden boards to create additional cubic capacity. But let's return to our maximum payload, which is just under 16 tons. So just remember, when you're loading gravel, you may only need to fill this body about 2/3 of the side heights. Otherwise, you will most certainly overload it. Okay, so this sets our baseline configuration for our session today. So keep this number in mind, roughly 16 tons. And in a minute, I will add a pusher axle to this and show you how we can increase the carrying capacity. But before we do that, I still want to show you that common scenario of this vehicle towing a bobcat trailer. So for this, I will need to add a coupling, and I will just choose a sample 50mm ball type coupling, add that to our chassis, and then choose a trailer, which will in this case be a center axle drawbar trailer. Now I've already used the template feature to save my own bobcat trailer to my personal library, which I'll select. And then all I need to do is add the bobcat to that trailer. So I'll go back to payload, choose detailed payload, and search for a bobcat. And I'll pick this left-facing option here. Now, in the default position at the front of this trailer, this would result in a tongue weight of about 420 kilograms, which is about 18% of the total gross trailer weight. Now, I've set up a range or an optimum range of about 8 to 12% for the tongue weight of the total trailer gross weight. You may have your own organization standards, or you may check this with your trailer manufacturer to ensure you have the correct transfer of weight to the vehicle. If I want to reduce this, and you'll notice that I have a red cross next to my own organization standard here, where the tongue weight does not fall into that range. So I will move this bobcat back slightly. I'll move it back to about here, and that will reduce the tongue weight to about 250 kilograms, which is about 10% of the total trailer weight. You can then use the tongue weight to determine the correct coupling spec for this application. So we'll know what the downforce is on that coupling, and we'll also know what the towed weight will be. All right, I'll return to our example now where we want to add the pusher axle and simply focus on the solo vehicle. So for that, I will reduce or remove our trailer again, and I'll also remove the coupling, and we'll just focus on the solo vehicle. Let me just remove that coupling as well. Okay, so now we are now ready to add our pusher axle, and again, just keeping in mind that our baseline vehicle can carry about 16 tons. So I'll go to the vehicle and add a pusher axle. The software will provide some tips and guidelines when adding an axle. There are quite a few things to consider here. By default, the software will add a 9-ton axle, which will validate this calculation against Schedule 23 of the Ontario SPIF regulations. We can obviously change that, but under Schedule 23, there is a tip here that we need to equalize the weight carried over all 3 axles at the rear. And to achieve that, we need to ensure that the weight carried by the pusher axle is a third or 33% of the total rear axle weight. You'll see here that this axle is rated at 9 tons. If you want to validate your calculation against Schedule 21, you could reduce this to 6 tons or less. But for our case studies today, we want to maximize payload, so we are going for Schedule 23. And you may have noticed that the carrying capacity on the axles would change once we equalize our load. So let me just go back to the original distribution, which was about 30%. You'll notice that the maximum permissible on the pusher is only 7.5, and the driven is 15. So that is when we don't equalize the weights over the axles. When we do equalize that weight at 33 1/3, those values will increase to 9 tons on the pusher and 18 tons on the driven. A few of the other values for the pusher that we can have a quick look at. The weight of this axle is about 900 kilograms. You can change that. The axle itself is a steering axle. It has to be a steering and lifting axle. In this case, we'll just make it a self-steering axle. That is sufficient for these regulations. It has to be a lifting axle because this axle cannot be deployed when the weight on that axle is less than 4 tons. The tires on this axle are the same as what we have on the front axle. They are also the 425s with a width of 16.7 inches to give us that carrying capacity of 9 tons on the axle. All right, so that sets up most of the specs for the pusher axle, but we still need to look at the spacing and some of the other warnings that the software will now point out. So for example, we still have a red cross here next to regulatory compliance. If I drill down on that and I drill down on that again, I'll see we are not complying with some of the dimension limits. To get more details about this, I can go to notes and warnings and just read up about this under warnings. Here I can see that the distance for the lift axle from the closest driven axle needs to be at least 99 inches. Also, the wheelbase needs to be at least 252 inches. So let's start with the wheelbase, and I'll override that value and make it 252. So that adds about a foot to the length of our chassis, which will increase our chassis weight slightly. I've sort of worked this out roughly. It should be about 50 kilograms for that extra foot. It is not a huge amount of weight, but if you want to include it to be 100% accurate, you can then update the front and rear chassis weights by 25 kilograms each. You could just click on the front axle and include 25 extra kilograms here, go to the rear axle and update that value there. All right, then next we still need to space the pusher forward slightly. So we'll click on this axle spacing and increase that to 99 inches from the closest driven axle. That sets up our chassis. Let's have a quick look at our body. Because we've now added an extra foot to the length of the chassis, this body is now a little bit too short for the chassis. So we don't have enough rear overhang for dumping. So what I'll do is I'll remove this body and add a slightly longer body. So let's just remove that and then go back to our dump body. And this time I'll choose a fully customizable template. I'll start off by just moving that 6 inches back from the cab, and then I can customize this body. I'll start off with the length. Remember, our original body was 18 feet. That was 216 inches. We've added a foot to the chassis, so we're going to go up to 19 feet. That is 228 inches. I will adjust the hinge position at the rear of the body here. I'll just move that forward slightly. I'll then go to the height. The long sills on the previous body were about 8 inches, so we'll keep that the same. The internal body height was 4.5 feet. That is 54 inches. And the floor is about 4.5 millimeters. That is about 0.2 inches. And then the headboard height, we can make 80. All right, I just want to have a quick look at the weight. The weight of the body, you may remember the original body, the 18-foot body, weighed about 2.2 tons. So for the extra foot we've added, I'm going to add on 200 kilograms and make that 2,400 kilograms for the body. That sets up this vehicle quite nicely. We now have a payload of about 18.5 tons. But if we just have a look at our total column here, we'll notice that we are being limited by the total permissible. So if we just drill down on that, you will see that it is actually the gross vehicle weight rating that is limiting our calculation. So remember, I mentioned this earlier on, we may need to spec a vehicle with a higher gross vehicle weight rating. So I will increase that to match the regulation limit, and that would be 36 tons, which happens to be 80,000 pounds. Now, this vehicle comes with many different options for the GVWR, and 80,000 pounds should be an option that's available. But it is important to check this with your chassis supplier, because only the manufacturer can change or specify the gross vehicle weight rating. Okay, now that we have a higher rating here, our payload increases to about 20 tons, and our rear axles are the limiting factor. Our front axle is actually quite light, and the front axle will make it, if we cannot fully utilize the 9 tons on the front axle, it'll be very difficult to achieve the overall 36 tons that are allowed for this vehicle. So there's also a warning about this. So again, if we go to the dashboard, you'll see there's a red cross next to weights. If we just have another look at our warnings here, you'll see that the weight on the steering axle needs to be at least 23% of the gross weight of the vehicle. This is why I've added this favorite measurement here, so I can keep an eye on that percentage. So currently we only have 17% on the front axle. So again, we will need to load this vehicle quite heavy up front. So let's move the payload center of gravity forward. And as I do that, you'll notice how that percentage increases and how the weight transfers, or more of that payload gets transferred to the front axle. So I'll move that forward until we optimize our vehicle and get over the 23%, and we now get a green tick, and we achieve a payload of about 23 tons. Okay, we're still slightly under on the front axle, but we've already moved our center of gravity quite far forward, and this may not always be practical to load the vehicle in this way. So this is as far forward as I'll go with that. And I'll just point out as well that having the center of gravity of the payload this far forward could affect the spec of the hoist, because the hoist will have to produce a little bit of extra force to lift this body with such a heavy payload up front. Nevertheless, we have 23 tons of payload on here, and we are pretty close to the total utilization of our 36-ton limit here. We are at 98%. So this is a pretty good result, except for the fact that we have to load the vehicle quite heavy up front. So what we can consider to improve our weight distribution is to see how a vehicle with a set back front axle would work. Normally, with a set back front axle, you get more weight transfer onto that front axle. At the same time, we will also end up with a slightly longer chassis, because the wheelbase will still need to be 252. So by moving that axle back about 1.5 feet, we will add 1.5 feet to the chassis length. So I will swap this vehicle, and I'll choose a 114 plus with a set back axle, and choose the one that already has the 252-inch wheelbase. You'll notice that the setback front axle now, our wheelbase is still 252. We need to add our pusher axle again. So for that, I'll go back to the vehicle and just add the pusher. Again, we'll need to equalize the weight over all the axles at the rear. And we'll need to increase that spacing to 99 inches. Okay, that sets up the chassis for our setback axle option. Paul, is there a question?
Hi, yeah, Martin. I just got a quick question a little bit earlier about the difference between SPIF 21 and 23 self-steering axles and auxiliary axles. And I think that you explained pretty nicely about how the equalization works and those differences there. And I just wanted to maybe add that you can actually end up seeing which truck it is that you're configuring against by looking in the notes, and it'll tell you that which one of those two trucks you're following, because that is something that they can trip somebody up easily, I think. So
Yeah.
just to point that out. Yeah, and that's all for the questions for now.
Thanks, Paul. Yes, that's a good one. I forgot about that. So if you go to notes, you'll see that this truck follows the Schedule 23 or designated truck 5 validation. Okay, so now that we've set up our chassis with the setback axle, we want to have another look at our body. I'll just move the body back slightly. Remember, we have increased our chassis length by 1.5 feet here, which means we don't have sufficient rear overhang with this body. So we could consider a slightly longer body. So I will increase our body length by 1.5 feet to 20.5 feet. So that'll be 246 inches. And at the same time, we will increase the body weight by, let's say, 300 kilograms to 2,700 kilograms. If we now have a look at our payload, we only have 19 tons, but the front axle is our limiting factor. This is actually a good thing because that means we don't need to load all that heavy up front. So I'll move the center of gravity back until the rear axles become the limiting factor. And you'll notice that we get more payload, and we now end up again with about 23 tons of payload and 24% on the front axle. So it is definitely easier to get weight transfer onto the front axle with a setback option. 23 tons is also exactly the same as what we had on the set forward axle option. So in terms of payload, there isn't a big difference, but there is an extra 1.5 feet of body length on this option. So you can decide which is better suited for your application. And again, when it comes to set forward and set back axle options, the other consideration may be if, for example, you're adding a snowplow to the front, you may prefer the set forward axle option because that'll give you a little bit more nose or front overhang to work with there. Nevertheless, we've got about 7 tons more payload on this vehicle compared to our baseline vehicle. Remember, we've gone from 16 tons up to 23 tons. So that is a pretty good overall result. In terms of turning radius, both the set back and set forward axles should produce about the same results because they both have a wheelbase of 252 inches. We can have a quick look at that, our turning radius here. You'll notice we calculate the turning radius curb to curb, 488 inches. That's about 41 feet. If we want to have a look at the steer angle on the pusher, we can just make that body a little bit narrower so that we can see the axles underneath. So I'm just going to reduce the body width to 34 inches so we can have a look at the pusher angles. You can also go to notes again where we show the calculated inner steer angle for that pusher. That is, at the moment, that's 21 degrees. And for this setup, the minimum by regulation would need to be 20 degrees. So because we actually need slightly more to minimize tire scrub, it would be advisable to ensure that this axle can turn by at least 21 degrees. So let's increase our body width back to, say, 102 inches, and we'll go back to our side view. Now, this is as far as we'll go in terms of optimizing this vehicle for Ontario. What I'll do next is have a look at our third case study, which is to see if this vehicle could work in Quebec. To do that, I'll go to the regulations and just change, I'll remove Ontario and just look for Quebec. Now, Quebec does not permit a vehicle with a second steer that is self-steering, as it is in this case. That second steer axle has to be steered by the driver. So we will need to swap this vehicle to a twin steer, as this vehicle is not compliant with the regulations. So to do that, I'll swap this vehicle and search for a 114 twin steer and pick this one without the front extension. Just move our body into position again. And you'll notice now that this is a valid combination for Quebec. This axle is now steered by the driver. Our payload is about 19 tons and our total permissible is 32 tons. So we are just slightly under that total permissible. And again, if we load slightly heavy up front, we should get to 32 tons, which would give us a payload of about 19.5 tons. So that is about 3.5 tons less than what we got in Ontario, but it is still a fairly decent payload for this vehicle. For our last case study, we'll want to have a look at to see if this vehicle could work in Alberta. So let's change our regulations again. And we'll choose Alberta. Now, Alberta has some fairly strict restrictions on interaxle spacing. So this vehicle would be limited to 24.1 tons overall. And that would give us a maximum payload of only about 12 tons. So quite a bit less than even our baseline vehicle. We could increase the carrying capacity here by stretching out the wheelbase to get an interaxle spacing of about 5 meters. But that may not be a practical solution for Alberta, and a more commonly used vehicle setup is actually a tri-drive chassis with a single steer. So let's rather swap our vehicle to that option. So I will search for, in fact, I'll search for a Western Star 49X with a setback axle and an axle layout that is an 8x6. And I'll choose the one with the 268-inch wheelbase. Now, Alberta also has minimum wheelbase requirements. For this vehicle, it would be 6.6 meters. This wheelbase is 6.8 meters, so that suffices. Now, in contrast to what we had with Ontario and Quebec, where we were always trying to load heavy up front, in Alberta, you would typically want to load heavy to the rear. So let's move our body to the back, move our hoist back into the doghouse. And instead of utilizing the space behind the cab for more weight in terms of body and payload, we'll rather put in something light here to minimize the weight transfer to the front axle. And I'll just use that space to add a sleeper cab extension. If we have a look at our weight distribution, we're quite heavy on the front, and that's because we are still loading heavy to the front. So we'll need to move our center of gravity rear and load slightly heavy to the rear to optimize the carrying capacity of this vehicle, which now comes out at about 16 tons. Now that is quite a low payload for such a big body. You could consider lowering the height of the sides to save a little bit of weight on the body. But this vehicle is also spec'd to tow quite a heavy trailer, so it is quite a heavy chassis. So let's see how much payload we could carry if we towed a trailer with this vehicle. So I'll go back to equipment and again add a coupling, and I'll choose a pintle hook. Just add that to the back of the chassis and then add a full turntable drawbar trailer. So this configuration is limited to 61.3 tons. The trailer has a unique restriction of 31 tons, which again you can read up about under the warnings here. So we do need to limit that to 31 tons, and I will just reduce the payload to 20 tons because our trailer tear is already 11 tons. That gives us 31 tons on the trailer, and we can increase the payload on the vehicle slightly to get us back to our 16 tons here. And that'll give us about 36 tons overall for this combination, which is obviously a pretty good result. Now, once you've finished your calculation, a good way to communicate the result is to generate a PDF. We'll just wait for that to come up. And here you can add your logo. You can annotate the PDF with a signature. You can add an approved stamp. You can import an image or add a call out to highlight something that is important. Once you've added all the views that you want on your report, you can also print, download, or email that. It's always a good idea to save a calculation. So if we save that, we can either save it to our personal library or the team library. In the team library, you can share calculations with colleagues. You can set up master templates, and managers can approve calculations before they are sent to your customer. Some of you may want to use the software in French. So under the user profile, you can toggle between English and French. This is as far as we'll go for the demo. Paul, are there any more questions before we go back to the slides to wrap up the session?
Yeah, yeah, we did have a question about whether the app includes US regulations, and so maybe if you'd like to show the number of regulations that we do have, we have like I answered in the reply there, we have the kind of the lowest common denominator of regulations in the US, which are those the US common size and weight regulations. And so those ones there, that's kind of like across the entire U.S. And then we've got regulations for each state for the state and sorry, for the interstate and national network roads. And so when you go down into those U.S., then those are marked with interstate. And then a lot of the states have also state level roads and anything else that happens to be particular to that state if we've gotten to it. So we do have a number of those regulations.
Yeah, thanks, Paul. Yeah, that is a good one to remember. So if you are selling vehicles into the States, you can make them compliant for those areas as well. Okay, I'll now switch back to the slides to wrap up the session. So let me just go back to our slides here. Okay, so just to sum up, here are a few things to consider when configuring a vehicle. For starters, spend some time on reviewing the technical specs of the vehicle. Ensure that you have adequate ratings for the axles, the gross vehicle weight rating, and gross combination weight rating, and that your tires have sufficient width and carrying capacity to achieve the desired weight on each axle. Check the front and rear chassis weight with your chassis supplier to ensure the weights match the spec. For pusher axles in Ontario, decide between a Schedule 21 and 23 and make sure the weight distribution over the pusher and driven axles is set up for the required load equalization. Remember that a pusher axle needs to be a steering and lifting axle in Ontario for Schedule 21 and 23. And for Quebec, the second steering axle needs to be steered by the driver. You should also consider the advantages and disadvantages of a set forward versus a set back axle. Remember that you'll get more weight onto the front axle with a set back option. For certain vehicle types, you may need to comply with minimum wheelbase requirements, for which you'd need to consider the effect on the turning radius. And then for Alberta, you may want to consider a tri-drive vehicle to optimize the carrying capacity. Now, it's impossible to remember all the regulations and manufacturer limits. So if you're using the TruckScience Axle Weight Calculator, you should always check the dashboard validation to ensure that your final build is compliant. Now, I've used our Axle Weight Calculator to work through these case studies today. If you would like to try the app yourself, please visit TruckScience.com to register for a fully functional free trial. You'll be up and running in under 5 minutes. We have 1 minute left. So, Paul, are there any more questions before we wrap up?
Hi, Martin. Yeah, we did actually have a couple of questions, a couple of good questions coming right at the very end. And so I did want to mention it that a question came through whether we can show the setup of a component from the manufacturer's perspective. So how the different characteristics of a particular component are. And so you can add in like a center of gravity and various other parts and change them on a custom component or a piece of equipment. And then there was a question about like weight distribution and viewing the passenger side So I mentioned that we do have a left-right weight distribution component to the app where you can take a look and you can't see the passenger side, but you can do the weight distribution on the left and right side, and for adding things to different sides of the vehicle.
Yeah, that's great. And thank you for those questions. And there is also an opportunity for us to engage with you one-on-one after this webinar. So I will end this session shortly, but before you go, please rate the webinar and leave any comments or questions you'd like to share with us. If you would like to set up a personalized demo of the app, just leave your contact details in the comments and we will gladly set that up for you. Thank you for joining us today. We look forward to your feedback. Goodbye, everyone.